Hey there. We're going to do chapter 13. We'll call this part 1. Chapter 13 deals with the monopolistically competitive market structure, and the key to understanding the monopolistically competitive firm is understanding that their market power comes from their ability to differentiate their product. Okay, keep that in mind as we go along. I'm going to call monopolistically competitive firms monocomp firms, just because monopolistically competitive is a mouthful. So, when you think back to monocomp firms, there were lots of small firms. They were all differentiating their product. There was ease of entry into their markets, and they had some pricing power, some market power. They're too small to gain market power because of their size. So the key, as I said on our intro, is that they are all going to differentiate their product. You are going to have all of these small kind of mom and pop, very competitive firms looking for an angle. Clothing companies are going to offer up slightly different logos and brands. Lawn care services are going to maybe edge your sidewalks, or they're going to mulch for you. They might all offer slightly different things to keep you coming back. Once you want that thing that they're offering you, then you are hooked on their differentiation. And in that sense, they become sort of a tiny little monopolist, because if you want that special thing they've got, you have to go to them. Now, they don't get to act like a monopolist and jack up their price way high, because there are still a lot of close substitutes. But the fact that they can raise their price at all and not lose all of their customers sets them apart from perfect competition. Okay, so that's where the strange name comes from, monopolistic competition. If you think about it, it's kind of an oxymoron, but this is what they have in mind. Little firms trying to generate market or monopoly power by differentiating. This is going to give them some pricing power. Okay, so as an example, clothing, how many of you guys buy a specific type of shoes because that shoe runs wide and you maybe have really wide feet? Or maybe you buy another brand that's very narrow and has a small heel because that works well for you and you're very loyal to that brand. Well, what you're loyal to is the differentiation that they're offering you, and if you want it, it looks like you have to come to them to get it, right? This is why they can raise their price without losing you. That's the secret to monocomp. So what does this mean when we have a firm that can start to raise its price? It's going to impact our demand curve and our marginal revenue curve. The demand curve for the perfectly competitive firm was perfectly elastic, horizontal, flat line. That's not going to be the case now, because if they want your stuff, your special differentiation, they have to come to you. So I've got the demand curve here, and you can see straight line, and I'm going to draw that in right now. There's our demand curve. But what I want you to recognize is that if you want to sell more product, you can't keep selling more and more product at the same price, right? Since you're on a downward sloping demand curve, if you choose a really high price, you don't sell any. If you want more customers, you have to start lowering the price, then you sell some product. So all I've done to get to total revenue is basically taken P times Q, right? The quantity you sell multiplied by the price you're getting it at. Keep in mind, you have to sell all of the quantity at the same price. So when we decide to lower the price to $14, this is going to generate $14 in total revenue for us. Now, if we want to sell a second unit, the only way we're going to be able to do that is if we are lowering the price. So we sell 2 units at $13 now, and that's going to generate us $26. So on and so forth down the line. In order to continue finding more and more customers, we have to keep lowering our price, and that of course means that you're going to find more and more people who are willing and able to buy. This is going to generate all of our total revenue numbers. Now, if you'll notice, revenue is rising all the way to here, and it stalls out between unit number 7 and 8, and then it starts actually falling. So we're going to be able to talk about marginal revenue as something separate than total revenue and separate from price. For the perfectly competitive firm, price was always equal to marginal revenue because every time you sold another unit, it sold for the price. That's not the case anymore here. Our first one is going to sell for $14 and hence generate us $14 in revenue. When we choose to expand output to 2, by expanding output by 1 unit, we actually only generated $12 extra. So marginal revenue is 12, even though price is 13. And if you'll look at this, this continues on this way. By expanding output to 3, selling 3 units at 12 actually only generates $10 extra in revenue for us. And you can follow this along here. Marginal revenue is going to peak there at unit number 8, and then it's going to actually go negative. So if you were to start graphing marginal revenue at every single Q, marginal revenue cannot be the same as the demand curve because our P's and our MR's are not the same numbers. So what we're going to see is that the marginal revenue for a straight line demand curve is always twice as steep as the demand curve. Demand and marginal revenue for any of the imperfectly competitive market structures, monocomp, oligopoly, or monopoly, all are going to have downward sloping demand curves and marginal revenue curves that are twice as steep. So what does this mean for us in terms of Q star? I'm going to go ahead and I'm going to draw in right away our marginal revenue curve, which you know is going to be twice as steep. And I also need to put in a marginal cost curve, because if we're going to follow our golden rule, MB equals MC, then we need to find where our MB, marginal revenue in this case, is equal to our MC. When you find that, I need you to jump down and grab your Q star. That's how you're going to get Q star in any of the imperfectly competitive market structures. And the same logic applies. If MR is greater than MC, then you should be making more quantity. When MR is equal to MC, you're at your optimal. And if MR is less than MC, then you, of course, have jacked it all up, right? You have not done the right thing. You're making too much. Okay. So any of these units between 0 and Q, right, are here. They're too low. You're not at Q star yet. Q star is, of course, this guy in green. And any of these units between Q star and out to here are these ones. They would have smaller marginal revenues for any Q than the marginal costs associated with them. Okay, you wouldn't ever want to make those. So how does this change our discussion of profit? When we're talking about profit, we are still dealing with your basic profit equals total revenue minus total costs. Okay, total revenue is still P times Q. Total cost is still going to be ATC times Q. And we just need to go and find where we're at now. So, just like I told you, always with any of these, start out where MR equals MC. That intersection is going to help you find your Q star. And from our Q star, we need to now figure out what is our average total cost and what price do we get to sell it at. In order to find the price, you have to go up to the demand curve, because the demand curve is the relationship between Q and P. If you choose to make this Q, this is the P that you will be able to charge for it. Okay, that gives us our green box like we've done before, and you can go ahead and figure out the math the same way that we have previously. So let's say that this is 1,000 units at $8. Of course, P times Q here then is 8,000. And when we want to figure out our total costs, we are going to take our Q star and we are going to go up until we run into our ATC, and that is going to give us our red box. Lucky for us, we've got more total revenue than total costs, and this is, of course, our profit. Okay, so let's say our total costs were 5. If our total costs were 5, then 5 times 1,000 would give us our total costs of 5,000. And of course, profit would be equal to $3,000. Okay. Critical thing you have to remember is when you're getting your P for your total revenue box, you've got to go up to the demand curve and grab it off of the demand curve. Okay? ATC works the same way. All right. Now, monopolistically competitive firms often take losses, just like perfectly competitive firms. So, if you're in a situation where the ATC is ever outside of the demand curve, you know that you're dealing with a loss. And the reason that you know that is because the minute that you go and you find your Q star, you are going to go to MR equals MC. You're going to go down and grab your profit maximizing level of output, and you're going to go up to the demand curve to get your P. P times Q gives you the area of your total revenue, and you got a problem because you can see automatically that you are not going to generate a green box that is ever going to be as big as your red box, because when you jump up here to your ATC from your Q star, you're going to see that your red box is bigger than your green box. There's a loss. So this area here represents an economic loss. And of course, in the long run, firms are going to want to get out. In the short run, they'd go through the same sort of shutdown analysis that we talked about in Chapter 12.